And welcome back, and we're on to the final day of the month. It's the 5 a day further maths, and let's go with the first question. Right, what do we have? Do the points, well, I'm going to label the points because I can talk about them. A, B, C. Do the points A, B, C lie in a straight line? Way of doing this is, it's the argument that if you have two parallel lines, well, two parallel lines, if they are parallel and share a point, must be a straight line. There's no other way of doing two parallel lines. So there's a few ways of doing this. So you could do it as a vector, or you could do it as a gradient. I'm going to do gradient. So let's work out the gradient of A to B. Now, because I've labelled these points A, B, and C, I've made it clear to the examiner what I'm doing. So therefore they can see that I'm working out the gradient between the 2 points that I've labelled. So A to B goes up 6 and across 3. So that's 2. And let's do A to C. So A to C goes from 4 to 20, which is up 16, and across 1 to 9, which is up 8, and so that's also 2. If this is a real exam question, it would say, explain your thinking. So I would say, yes, they are, as MAB equals MAC. I'm explaining the gradients are the same, and they share point A. So it's the two things. One, same direction. Two, share a point. First question done. Next question. Prove that the product of two odd numbers is always odd. Now, the first thing to note is these are not consecutive numbers. So I'm going to let my numbers be. So let numbers be 2n plus 1 and 2n plus 1. And just so I've written it down because I like to be precise. So n and m are both integers. If you haven't seen the Z symbol before, it just means it's an integer. Then what I'm going to do is I'm going to do the maths part. So what am I doing? So prove the product of the two. So I'm going to just work out. So you don't need to say, I am doing the product. You can just do it. The examiner will know what you're doing. And that's going to give me 4nm plus 2n plus 2m plus 1. Then I need to demonstrate that this is an odd number. So I'm going to say that's the same as 2nm plus n plus m plus 1 of form 2k plus 1, therefore odd. I've answered the question. I've shown it's odd. I've done my sort of algebra bit. I've done my setup. That's okay. Next question. Well, I'm assuming those are powers, not fractions. Let's assume they are powers. So, this is a difficult question. How are we going to do this one? I think there's a couple of ways of doing it. I think probably the easiest way of doing it, I'm going to write everything in terms of root 2. So this one here is root 2. I'm sure we're all okay with that. This one here is root 2 5 times. So it's root 2, root 2, root 2, root 2, root 2. And root 2 times root 2 is 2. And root 2 times root 2 is 2. And 2 times root 2 is 4. So in other words, this is all the same as 4 root 2. So really, this is saying what I've got root 2 plus 4 root 2 all to the cubed, which is 5 root 2 cubed, which is going to be, let's go over here. Well, 5 cubed is 125. And I've already said that 2, well, actually, let's write it out again. So root 2 cubed, so I'm going to write it down here, and a separate space. So root 2 cubed is the same as root 2 times root 2 times root 2. This is 2, and so therefore it's going to be 2 root 2. So therefore it's 125 times 2 root 2, which is the same as, I'm saying the root 2 an awful lot here, which is the same as 250 root 2. Wow, that's a great little question. I like that question. Well done if you got that. The other way of doing it, which I was considering doing, but I thought might be quite messy, you just write out the brackets and just expand the brackets, and you'll find a lot of the halves become whole numbers, and it should fall out the same way as well. I think arguing my way is a bit quicker because it just sort of resolves the whole 5/2 issue at the outset. Next question, and final question of today, and indeed final question of January. Looks like a fairly straightforward trigonometric question. I've got a sine and a cos, so the only way I can resolve this is to turn them into tan and rearrange to the other side. So let's do that first. So let's write down what I've got. So I've got 5 cos x equals minus 4 sine x. Okay, then I'm going to divide both sides by cos x and minus 4, and that tells me that tan x is equal to minus 5 over 4.
Now, because it's between 0 and 360, and actually if I draw a quick sketch, it's easier to explain. So the tan x curve comes up, down, up again, and to the start. And minus 5 over 4 has 2 solutions. One's just above 90 and one's just above 270. So I know what I'm looking for. So let's get my calculator out. So I've got my calculator out. That's going to tell me that x is equal to, let me just type it in. So inverse tan minus 5 over 4. X is equal to minus 51.3 degrees. Now, because that's not within my range, I'm going to keep adding 180 until I get the numbers I need. So add 180, that's going to give me 128.7 degrees. And add 180 again, and that's going to give me 308.7 degrees. And if I add 180 again, it'd be outside my range, so I'll stop there. So therefore, my final answer to the final question of January is going to be 128.7 degrees and 308.7 degrees. And that is January and today done. Well done if you got all of those. As ever, do like, subscribe, and we'll start February tomorrow. Thanks all. Goodbye.